Deep inside the abandoned reactor structures at Chernobyl, in rooms where radiation still overwhelms human cells, something unexpected began to spread. A black fungus coating fractured concrete and rusting metal, growing in silence where almost nothing else can survive. It clung to the walls of a place that should have been lifeless. For a long time, it seemed like just another stain left behind by disaster. But as the ruins were examined more closely, something unsettling emerged. The fungus was not drifting without purpose. It was aligning itself toward the radiation, creeping in the direction almost everything else tries to escape. Its cells were saturated with melanin so dense it turned every colony a deep, glossy black. When exposed to radioactive sources in controlled experiments, the fungus reacted in a way that defied expectations. Instead of breaking down under the assault of ionizing particles, it increased its rate of growth. Samples placed near cesium emissions expanded faster than cultures kept in safe conditions. The radiation that tears through DNA in most organisms appeared to push this one forward. Researchers later placed the same organism in orbit, where high-energy particles sweep through every surface. Inside that environment, the colony thickened more quickly than the control sample kept on Earth. A radiation sensor beneath it registered a small but consistent drop in exposure as the mold expanded. Even a thin layer of living tissue created a measurable shield around itself. The underlying process remains unclear. Melanin absorbs radiation, but the way these cells respond goes far beyond simple protection. The pigment shifts under exposure. Metabolic activity changes. Patterns emerge that do not match familiar biological behavior. No confirmed mechanism explains why this organism moves toward radiation, strengthens under it, or forms a barrier that should not exist. Inside the sealed rooms of the old reactor, the fungus continues to spread across surfaces long abandoned by people. It moves through quiet chambers where the air is still and the dust remains untouched. The radiation that keeps the living world at a distance has become the signal this organism follows. It advances in the dark, cell by cell, drawn deeper into conditions that erase almost everything else. And if a life form on Earth can grow stronger under forces that destroy most biology, it raises a deeper question. In a universe filled with radiation storms, cosmic particles, and ancient worlds shaped by far harsher conditions than ours, what other forms of life might be built for environments we consider impossible?